Now that we are just a minute away, first of all, I'll introduce myself. My name is Lydia Skinner. I'm a supplier executive at Distrelec. My name is not Adam Self. That's just my colleague. That's just the name under the account. So yeah, it's Lydia. So this is the first in our Distrelec webinar series. Oliver will be running you through an introduction to Eva. And we'll be also answering kind of a Q&A. So any kind of queries that you have, please use the Q&A box, and then we'll kind of come to a period at the end where we can kind of go through, any questions that you've got about the technology, installation of the technology, or, purchasing from Distrelec. So you're welcome to ask questions then. I will also just reiterate that the session will be recorded. You're welcome to have a recording of the session once you finish. I think that will be emailed to you. But just to let you know, it's just for kind of marketing purposes. So yeah, I'll let Oliver continue.
Excellent. Thank you, Lydia. It's a pleasure to be here. Obviously, as Lydia said, I'm Oliver. I'll be joined today by my colleague, Craig, who will be giving you a live demonstration of Eva, our affordable solution to automation. It's absolutely our pleasure to host this webinar in conjunction with our partners at Distrelec. They're one of our best partners, reseller partners in Europe and across the world. So it's really great to be having this webinar with you today. So today we're just going to, we're probably going to take about 45 minutes of your time. I'm going to run through the specifications of Eva, how to program the robot, how easy it is to use, before we move on to a live demonstration and demonstrate to you how simple and straightforward it is to deploy robotics within your facilities. And then I've got some really great applications videos of existing live applications that might give you an idea of some of the potential deployments that you could make within your factories and within your manufacturing facilities. So without further ado, I'll kick us off today. So Automata is a UK-based company. We design and manufacture our own 6-axis industrial robot called Eva. Available from under €9,000 from the Distrelec website, either on its own or as part of a package with numerous end-of-arm tooling that we'll come on to later. Can carry out really simple tasks that can be programmed in under 30 minutes by anybody with little or no programming experience. It's that easy to do. My 6-year-old daughter can actually operate the robot better than I can. That just gives you an idea as to how simple and straightforward it is. And programming is done through our own proprietary software that I'll come on to shortly. But we also offer a REST API and a Python SDK for more complex applications or for applications where you need to communicate with other external pieces of equipment. And Automata and Eva really are industry-leading setup times and payback periods. And we'd set out to make automation as affordable and accessible as it ever has been before. There's lots of people out in the market trying to do similar things, and lots of our customers will tell you and talk about how simple and easy Eva is to use, which makes it one of the best choices going forward. I just want to dive into some of the technical specifications that you can see here, and this document is available on the Distrelec website on the Eva page. But in short, Eva is a 6-axis industrial robot. What that means is you've got 6 individual degrees of freedom. So you've got an axis at the base of the robot. You've then got a shoulder movement, an elbow movement, a forearm twist, and a wrist, as you can see split up on the image of Eva on the right there. And that gives you a reach of 600 millimeters. And we often refer to Eva as a robotic arm. And that's probably the best way to think about it. If you think about it as your own arm, as I just described it then, you can picture how you can build in different applications based around that kind of philosophy. Eva's got a maximum payload of 1.25 kilograms and a repeatability of plus minus 0.5 millimeters. The other very, very unique thing about our robot Eva is that the controller for the robot is actually built into the base underneath axis 1, as you can see on the picture on the right there. And that just means that it's a very small self-contained unit that takes up a maximum footprint of 160 millimeters by 160 millimeters. This gives you the flexibility to deploy Eva on machines that already exist or around machines that already exist without worrying about taking up extra space with external controllers or bulky stands that you need to deploy on site. And we also use 24 volts DC, making it as accessible as possible to most people. At the bottom there, we've got reference to the different types of electronic interfaces that we have available on the robot. You've got 2 analog inputs and 6 digital IOs. So that gives you the opportunity to communicate with plenty of other external pieces of equipment or external PLCs using standard IO that is available on the robot. You've got an e-stop on there. You've also got a safety circuit stop as well. And connections are really, really simple and straightforward. There's no complicated special circuits required for Eva. If you want to get Eva up and running, you've got Ethernet built into the robots. You've also got access to Wi-Fi. Wi-Fi is a great tool on our robot Eva. It allows you to connect Eva up to your own factory Wi-Fi and dial into it remotely, or you've got the opportunity to connect directly to the robot using the access point that it will emit. If you've got any questions or anything on here as we go through, as Lydia said earlier, drop them in the Q&A box. We'll pick them up at the end. I just want to talk about choreograph. Craig's going to give you a demonstration of choreograph shortly, so that you can see how easy it is to use. But we designed and built choreograph to make it as simple and straightforward for our customer to program the robot with little or no programming experience. So what it gives you is a really, really simple GUI that allows you to interact with the robot in real time and build what we call toolpaths in order to program the robot to tell it to go from point A to point B and so on and so forth. It's great for really, really simple or really complex tasks, as you'll see in some of the videos that I'll show you later on. You've got built-in grid functionality, which allows you to pick and place items from perhaps a tray or place items into a box. You can use multiple different users and permissions on the robot. So once somebody's programmed it, you can have a user account dedicated to somebody that will just come in and hit start on the program and allow it to run. It can be programmed in under 30 minutes. And one of the strongest points here is that it can be accessed directly through a web browser. There's no additional software, there's no disks required. You can load up the robot, load up a web browser on any device, whether that be a laptop, a PC, a mobile phone, a tablet, and you can run those programs and run those toolpaths without the need to go in and have somebody have a special controller in order to be able to run it. It's obviously preloaded with choreograph, so all you have to do is just hit play and away you go. The GUI obviously makes it very, very simple and easy to use. So you can see what you're doing as you go along, and it's very, very intuitive. And you can then preview all of the actions that you're doing before you upload them to the robot. You're not going to run into any incidents when you're actually live in the field. So I'm now going to show you the live demo by my colleague Craig, and you'll see this is a pre-recorded demo, so you'll be able to see it as it happens. But if you've got any questions during the demo about the previous section, please drop them in the Q&A. We'll pick them up at the end.
Fantastic. Thank you, Oliver. Alex, if you could cut those slides, we're going to go live to our little demo room. I'm very much surrounded by robots at the moment. I've got one behind me here, but I'm going to pop round into the other frame here, so we can use this robot here. So this is Eva. As Oliver said, we're talking about from box to toolpath in 15 minutes here, and this is how the robot comes out of the box. So you come through the assembled. All we've done here is added a gripper. This is a Shunk EGP50 gripper. We've got a little mounting plate here and a simple cable from the gripper to the head I/O. That's just sending digital signals to and from the robot to the gripper so we can operate it simply. In terms of mounting the robot, which is probably your first concern, we've just got 4 M6 bolts in here, secure it down nice and simply. So if you want to either build a cart to move it around, or build a table, you can just drill through a sturdy table and get that up and running quickly. Again, as Oliver said earlier, oftentimes our customers are moving it around. And actually you'll see here, we've got the base of the robot, and that houses the controller of the robot. So there's no external things to move around with it. You can take basically just this unit, put it on one toolpath in the morning, put it on another in the afternoon, and you're absolutely grand. It's just a case of plugging in the power and the emergency stop button, the big red button, which is here. You know what happens when we hit that, everything stops. So yeah, as I say, just plug in the power, plug in the e-stop, and then I've also plugged in an Ethernet connection just for today, so we can connect to my laptop. Again, as Oliver touched on earlier, we've got a Wi-Fi connection connecting it to your main network, or indeed you can connect to the robot as if it was a Wi-Fi network itself by connecting directly. You see we've got this nice little label on the front here. You won't be able to read it, but it's got my Wi-Fi password on it there. So yeah, EVA is a 6-axis industrial robot. So we've got axis 1 here, 2, 3, 4, 5, and a final rotational axis here, which you should be able to see in a second. I am going to unlock the robot so we can start moving it. So what you can see on the front here is we've got 2 buttons. And this button here is what we call the back driving button. And if I press that, it allows me to release the brakes on the robot, and I gain full control of it. So I can start to move around to the sort of positions that I want. And you'll start to see the kind of range of movement that we have on the robot. So I'm going to go right out here. You'll see we've got 600 millimeters in every direction. So if you imagine just a circle around the robot and a sphere right up to the top, it's probably come out of shot with the camera, but we can fully extend right up there. And as touched on earlier, we've got that axis 6 final rotation as well, which is one that sometimes people miss. So 6 axes of movement means 6 degrees of freedom. So you've got movement through X, Y, and Z coordinates. And the back driving function is a really important part of what makes EVA simple and ready to program those first 2 paths really, really quickly. You can drag and drop into all the positions that you need. There's no complex programming. You don't need to know any coding. It's really just a case of dragging it to where you need it and then stringing those things together, which I'll show you how to do in a minute. The second button, which I'll tell you, is the waypoint button, and that just allows us to save those positions that we've moved the robot into. So if I was to move the robot down here, and I wanted to save that for my programming needs, I'd pop that button, and the robot would save the exact position that the arm is there, and also the X, Y, Z coordinates of the tool center point, which is just underneath there. So what we're going to do today is show you just how easy it is to program those simple toolpaths. So what I've got here is a nice little dumbbell here. I think it's from one of Oliver's sets, one of his heavy gym sessions there. That's ½ a kilo. And I'm just going to pop this down here. And we'll show you how easy it is to get one of those pick and place applications up and running. So what I'm going to do is share my screen. So this is choreograph. And choreograph is what Oliver touched on briefly earlier. That's our GUI, our way of programming simple toolpaths. So what you'll see there is a live representation of the robot in 3D. And you can see with the point 1 there, that was the point I just saved on the robot. Now if I grab that back driving button and move the robot, you'll see the 3D render there following around in real time. And if you remember, I said we have the X, Y, Z coordinates of the robot. You'll see them live just there, the X, Y, and Z. They follow if I move the robot around as well. So you have a nice, easy way to I'm having some technical difficulties. There we go. Does not always love Zoom. There we go. So yeah, you'll see that X, Y, Z coordinates following the robot around there. So yeah, I've got my dumbbell over here. So to program that, I'm going to first drag that robot down using the back driving as we saw earlier, and I'm going to put it in a position where I'm going to pick it up. So right over the center point of the dumbbell there. And then, as discussed earlier, I am just going to save that waypoint. And you'll see number 2 there. And when we pick up, what we usually want to do is pick up and we want to go straight up, if you can see like that. So we don't want to go across, we don't want to go to the side, we want to go down, we want to come vertically up by a certain amount of a certain amount of millimeters. So instead of dragging and dropping that, what I'm going to do is take this point, and I'm going to use this function here, which is the clone function. That basically just duplicates that waypoint. And then I'm going to use the absolute movement function here. You'll see those X, Y, Z coordinates again. And I'm going to move it through the Z axis. I want it to move straight up, as I said. And I will shift that up to around 220. And that should do just fine for me. So I'm actually going to start with 0.3. I'm going to send it down to 0.2. And then I'm going to bring it back up to 0.3. So at 0.2 is our pickup point. That's where we want to lift up the dumbbell. And in order to send a signal to the gripper, I'm going to use the set output function. Again, as we discussed earlier, I've got the gripper connected to the robot's end effector I/O. So I'm going to use the digital I/Os on there, and I'm going to set 2 of them. So you need 2 digital signals in order to change the state of the gripper from closed to open. And I'm going to find out what state it's in at the moment. And I can do this on the choreograph homepage. So this gives you live status of anything on the robot. It's the page that you come to when you sign in. You can find out the exact joint configuration of the robot, which is the joint angles, the speed that it's running in, the run mode, and you can also find out what states the outputs are in. So at the moment, it's open, and it's digital 1 being on 1 and digital 2 being on 0 that opens it. So if I want to close the jaws, I'm going to have to put digital 1 to a 0 signal and digital 2 to a 1 signal. So I'm going to go back into our toolpath here. I am going to keep digital 1 there on 0, and I'm going to put digital 2 to 1. And what that's going to do is allow those jaws to close at that point. And good practice here is just to put a weight in. So you can see our little clock here. And that's just to make sure that the robot doesn't rush ahead of itself. It doesn't pick up anything too quickly. And usually when I'm programming in a pickup, I'll put in a half-second delay there. And that's just good practice to make sure that things run properly. The other thing I'm going to do for a toolpath that picks things up is make sure the jaws are set to open at the very start of the toolpath. So before anything kicks off, we want to make sure the robot's in a state where it's ready to do what we want it to do. So I'm going to set base digital 1 to 1. Come on. There we go. And I'm going to set base digital 2 onto 0. And it is not loving Zoom today. Month in lockdown over Zoom already. Too many Zoom quizzes over the past month. It's too much. There we go. Back on, and we set that to 0. Perfect. So as we said, what that's going to do is at that start position, it's going to make sure things are open. It's going to start at 0.3. So I'm going to move down to 0.2. It's going to close. It's going to wait half a second, and it's going to move back up to 0.3. And I'm slightly tugging on my Ethernet cable here. So we'll see if we have any more luck there. Perfect. So I'm going to upload that toolpath to the robot. That means it's housed on the robot's controller. And it's ready to run, basically. In order to start the toolpath, we've got to use this button here and send it to the home position. That's the first point on the toolpath. So send it to 0.3 there. And then I'm going to hit play and just see how our first pickup goes. And once we've programmed the first pickup, I'm going to get it to put it down right over here. But we always kind of test as we go when we're building these toolpaths. So I'm going to set it just to loop once, and I'm going to run it in a mode called teach mode. Now teach mode is a really important mode for the robot. When you're programming your first toolpaths, it limits the speed of the robot to 250 millimeters per second. And that means basically that the robot is not running too fast. If you've programmed a mistake in your toolpath, then it's unlikely to drive into something at a high force or even injure someone working in the vicinity. But as ever, when I'm running my first toolpath, I've got my emergency stop button right here. I'm ready to whack if anything goes wrong. But I'm pretty confident that this one should be okay. So we're going to hit run. And there we go, we've got the robot moving down, picking up the dumbbell there, nice and simple. So what I want to do now is program it to move over here and put the thing down. One of the things that's nice and easy about this, this demo in particular, this toolpath, is that the robot is putting the dumbbell down in the same way that it was picked up. That's one of the things that we find people can often underestimate about robots and simple toolpaths, is that if you got a human being doing a task, they've got a wrist, and your wrist is brilliant. It gives you a full amount of flexibility. You've got fingers, you can manipulate things as you go. It's much more difficult for robots to manipulate things in flight. So if you're looking for those initial easy to program toolpaths, one of the things I'd recommend is if you have a application where something's being picked up and put down in the same way, then that's a really great place to start. And Oliver will have some great examples of those later in the webinar. But for the moment, we are going to keep on here. So I'm going to move over here. We're going to save a waypoint again. Dear me, it's not loving my cables today. They took away my usual robot. It's down in Aldershot doing something exciting today. Without me, sadly. Gosh. So I am going to flip over to my other screen now just to show you programming the rest of this in real time. So you should be able to see just my video there. So I've saved that point. And I am going to add it to the toolpath. And I am going to save one down here, add it to the toolpath. And again, I'm just going to do what I did before, which was set the jaws of the gripper to open. So that's our 1-0, if you remember. And that's going to put it down nice and easy. I'm again going to upload that. I'm going to send it to our home position. And we will have a really quick pick and place programmed in live time there for you, with only minimal technical difficulties on Zoom's side, which I'm going to say is a win for me today. So yeah, that's a really quick, really dirty demonstration of how simple toolpaths are really easy to program. There's a whole range of things that the robot can do, and we've got, as I say, Oliver coming up very shortly with some much more interesting videos, but that will give you an insight into just how quickly it is to get set up and running. I think I've run slightly under my 15-minute goal, which I'm quite happy with.
There we go. Excellent. That was. I hope you all found that
fantastic.
Beneficial. Let me just try.
Thank you, Oliver.
There we go. That's better.
Fantastic. Thank you.
There we go. That's better. I hope you all found that beneficial. That was a video we actually recorded about well, a little while ago that I wanted to play against you today. Craig's actually unavailable, helping to deploy a project. So it's good to have something that we can play back to you so you can see it working in real time. But there was lots and lots of information to take away from there, and I think the main takeaway, and the one thing that we constantly shout about with Eva, is how easy and simple it is to program. That was done in less than 15 minutes, and I think it was very, very clear that it doesn't take a lot of knowledge or experience in order to be able to do it. So where I wanted to go from here is I wanted to show you some live examples of where we've deployed Eva, just so it might help you to envisage your application in real time, and other people that have already carried out those the hard work, I guess, in deploying it. Just to give you a bit of a caveat here, some of these videos are a bit rough and dirty, filmed in real working manufacturing sectors, but I hope that gives you the best examples of Eva already being deployed. So this first one here is a video of Eva machine tending. Machine tending can refer to any kind of deployment where you're using a robot in order to load and unload or support the working of an existing piece of machinery. So the machine that you can see here is a press, and you've got Eva. It's probably one of my favorite videos, actually, this one. So Eva is obviously on the is mounted there on an aluminium profiling that's just been bolted to the front of the machine. I like that more than anything because having known this customer when they first purchased their robot, they actually used this robot for this application in the morning. Eva's then unbolted and moved to an entirely different application in the afternoon, which for us just shows how versatile the robot actually is. But what you can see there is Eva picks up the metal bracket on the left there. It's then fed into the press. The press operation is carried out, and then the completed parts are dropped into a bin on the right-hand side. And this is a really good example of where you can deploy a robot without the need for an expensive PLC or without the need for any other expensive kinds of safety equipment or other alternatives. You can just bolt the robot to the front of the machine, carry out the operation that you want to carry out, and allow it to do the job that it needs to do. This setup would have probably cost somewhere in the region of 11,000 euros, which is considerably less than even if you were going to try and purchase a robot from other manufacturers that already existed on the market. Here's a couple more machine tending videos that I just wanted to share with you, and I'm sure this will be familiar to most people who operate a CMM machine within their facilities, which most manufacturing shops do, and it's quite common practice. On the left here, you've got a much smaller, much cheaper CMM machine, an Abalink CMM, but you've just got Eva is picking up parts that are usually presented in a tray, loads them onto the CMM machine on the left there, and the majority of the application is clearly carried out by the CMM machine in this case. But it's very, very easy for Eva to just get involved in the loading and unloading. What you would probably find is you might inspect 1 in 50 parts previously. Having a robot or deploying robotics in this kind of example allows you to inspect much more parts, much more frequently for less cost. And the example right here is a much, much larger CMM machine, but the concept remains the same. Eva comes down, picks up the part, places it inside the CMM machine, and allows the operation to be carried out. So it's this kind of application, this kind of machine tending we see all the time, and for a robot that costs less than 9,000 euro in comparison to the cost of somebody to operate that CMM machine manually, it makes absolute sense to use robotics to do that kind of task. Very simple and straightforward. I'll flick on to the next slide here. So this slide is actually for testing and inspection. And some of you that have perhaps visited the Automata YouTube page will be very, very familiar with this video. It's one that we've shared a lot. It's probably one of my favorite videos. It was one of our very, very early customers at Automata. I'll hit play because it's quite a long video. I won't make you watch it all, but this company actually sells testing equipment for car stereos, as you can see in the video here. And the operation, the testing operation has to be carried out by a human previously. So you can see there's a small camera mounted to the end of the robot there, along with a small stylus. And what's actually happening is that the camera is reading the screen that you can see there, feeding the data into the box on the left. And then it's telling Eva what operation to carry out the testing. So instead of having somebody sit there and press buttons for days on end until they get an answer or they get a failure, then we're able to carry out these processes using robotics and a little bit of machine vision in order to be able to save that person's time and the cost of that person doing that application. And this company, we're actually selling this finished solution into the big automotive suppliers to allow them to test their car audio equipment. So the next videos that I've got here are assembly and sorting videos. And again, assembly is another really popular application for us, especially in manufacturing environments. The video on the left here is a gluing application. Gluing is often one that when I talk to customers about, we don't support inline gluing, but this particular application is just a spot gluing application. So you can see the robot comes down there, dispenses the glue onto the circuit board, and then moves away. These kind of applications are really simple and straightforward. It allows you to get better repeatability than you would perhaps get with a human operator carrying out this task, because a robot is only programmed to go to one place time and time again. And as long as everything else lines up, then you will always get a perfect application. Whereas sometimes there is always an element of human error when you're asking somebody to do that process manually. The video on the right here was actually produced by one of our systems integrator partners in Italy, and they use EVA to place clips into plastic bumper parts for a popular German car brand. And you can see EVA here is built into a much more complex cell design. The integration is obviously considerably more expensive and much has taken many more man hours to achieve, but the concept is the same. You're using a very affordable robot to carry out a really simple application that previously you might perhaps have they did use much more expensive robots in order to carry out the application. They didn't need to do that anymore because they had a robot like EVA available to them, ready to use. And then the final part of Automata's business is lab automation. So EVA, being small in size and having a relatively low payload, lends itself perfectly to laboratory automation. And whether that be automation within a pathology lab or medical device manufacturing, we have the software protocols in place in order to be able to handle those kinds of applications. But this is just a really simple video of EVA working in an atmospheric chamber where perhaps you would sometimes see somebody with their hand through the gloves there, operating and working with these microplates, but doing it manually rather than having it automated. And this particular video was filmed with a company called Don Whitley Scientific, who are based in the UK, but EVA still lends itself to lab automation across the board. We've seen lots and lots of success in this space. EVA as a product currently processes 100,000 COVID tests a day in the UK, which we're very proud of. And if you've got any specific lab automation requests, we're more than happy to speak to you about it and talk about what we can do and what we can offer in that sector. So that's really nearly it from me today, other than the Q&A, which we'll go through shortly. So what can we do to help you going forward? So Automata have a world-class forward deployment team and applications team, and we're offering free support to all Distrelec customers to allow you to get the best advice possible to deploy EVA within your facilities. So there's an email address on the screen there, automata@distrelec.com, that you can send your inquiries directly to. And the other alternative, of course, is we're more than happy to see videos of your existing applications, or feel free to send us the parts that you're already manipulating and how you're doing that. And we can give you the best advice possible, and it will always be impartial. If we don't think EVA is the right product for you, we would always tell you that. We would never sell somebody a robot unless it was the perfect robot for them at that time. So I'll move on to any questions. I can see there's a few questions in the chat already, so I'll go through those four first, and then we'll pick up any extras that come in as they come in. But if you have got any questions, please drop them in now, and we'll go from there. So the first question is, can the robot be mounted horizontally, or does it always need to be mounted vertically? So the answer to that is, right now you can only mount EVA vertically, and that's because there's a gravity value accounted for when you're doing the programming. However, we've just about to finish the work on being able to mount EVA horizontally as well. So within the next few weeks, you'll be able to mount it in an alternative way. Now, that's the other huge benefit of Automata and the Automata software over lots of other providers. Choreograph is constantly being updated. We have new software updates every 2 weeks that are constantly launching new features, and we do that based on customer feedback. So if you've got a robot and you're already using it, but you think there's a feature that you would like to see added, we're able to build and deploy features like that very, very quickly, which is why we've done such thing here. We've got another question about using EVA as a medical device in medical device manufacturing. Yes, absolutely. Happy to pick that conversation up offline and chat a bit further about it. Please use the email address on the screen, and we'll talk you through what we've done previously and how we validate the steps that we're taking. Somebody else has asked about the Choreograph software and is it hosted on the robot? So the answer to that is yes. It's all hosted locally on the robot, and you can connect it up to the internet in order to gain the software updates that we provide free of charge. And then the last question I've got here is a really, really great one about collision detection and collisions stop. So we have something called equipment protection feature, which is a version of collision detection, but it's not safety rated. So in the event of a collision with another piece of equipment or a person, the robot will come to a stop without causing any damage. And that's a feature, again, that was built into software that we launched a couple of months ago. And so essentially, yes, it gives you the collision detection opportunity. That's all the questions that I've got. If there are any more, please feel free to drop them in the chat. Otherwise, I'd just like to thank you all for coming today, and it's been great to meet you all. Got another question about applications in the food and beverage industry. So yeah, absolutely. I haven't shared any videos in this particular presentation. That's a really good point. So we provide the option for what we call a polylaminate cover to cover EVA, just to protect food environments from robot dust or ingress, to protect the robot and to protect the food. But yes, you can use it within the food and beverage industry.
I just have a question that's come through around end of arm applications for EVA, what the various ones are.
Yeah, the different types of end of arm tooling. So on the head of the robot there, you've got a mounting plate that's designed to ISO 9409, which just means that it takes 4 M6 screws arranged at a 40 mil diameter, and it's compatible with all off-the-shelf grippers. We use, as Craig alluded to in the video there, we use Shunk or Zimmer or Soft Robotics, and all of those kits are available through the Distrelec website as part of a package with EVA, or available separately if you've got a particular need or requirement.
There's also another one that's just come through on the chat. I think it's in relation to the coordinates. It says only X, Y, Z, where are A, B, and C?
Yeah, absolutely. So the X, Y, and Z coordinates refer to the points for the end of arm tool. So you'll have it either operate by working out what point in space you're trying to get to and moving between those points. So you don't have to configure each individual axis, just the tool center point.
Perfect, thank you. I think you slightly went over this before, but there's been another question around the safety features available.
Yeah, absolutely. Very good point. So EVA is shipped with a category 0 emergency stop function, and this can be upgraded using the additional safety port. So you can use additional safety equipment like light curtains or additional e-starts, or in fact wiring into the existing safety circuit within a factory. And we can also provide specialist advice on that as well if you need it.
I think that's it for the questions that are in the chat. We've still got a few more minutes if anyone wants to add anything else. Did you answer the question about the collisions, Oliver?
Yes.
Yeah,
I think, yeah.
that one.
Yeah.
Is it possible to define protected areas?
Yes, it is. Yes. Yeah, I've just picked up that. Yeah, I've just picked up that question as well. Yes, absolutely. So one of the very, very latest features of Choreograph is you can define what we call no-go zones, which is just a plane in space where the robot can't move through. So you can build in the environment around the robot so that when Eva is plotting movements from point A to point B, it won't collide with those areas that are considered what we call no-go zones.
I've just had a question come through around upgrades. So are the upgrades to the software rather than the hardware?
Yeah, so all of the upgrades are software-based upgrades. The hardware that we've already designed and built is ready to go and meets the standards that we've already expected. But we provide, as I say, every 2 weeks we provide software updates that includes new features based on customer feedback and requests.
And I'm not sure if you've seen this one. There's just been a question about security level for cooperation with humans.
Yeah, just saw that one. Yeah, so we class Eva as an industrial robot, which means you'd need to carry out your own risk assessment based on local regulation to define whether it was safe to deploy without any security, without any additional safety systems, or whether you'd need to look at additional systems such as perhaps a light curtain or a laser scanner that we can advise you on based on your particular requirements.
No, I think we can wrap it up there then. Thank you so much for hosting this, Oliver. I'm not sure if you want to give a bit of an outro and tell people where they need to go.
Yeah, absolutely. Thanks, Lydia, and thanks for having me, and thanks everybody for coming. Obviously, feel free to please do visit the Distrelec website for lots of information about Eva. There's some case studies on there that you can download and some video case studies as well that you can watch. But as I say, if you've got any specific questions around the product or you need any support, please do use the automata@distrelec.com email address, and we'll pick those up, and we're more than happy to have further discussions around specific needs or requirements or your particular application in order to help you to get to success. But thank you all for coming. I really appreciate your time.
Wonderful. Thank you very much.
Thanks.